Good evening to all on channel and frequency. This is Keith, ZS6 Hotel India. Thank you for joining us for the Power Hour Tech Talk with VarAC from our special guest, ZS2OK, Alistair, ZS2OK. So I'd like to thank everyone for being here tonight, and a quick introduction on Alistair, which I've stolen from Alistair's QRZ page. He doesn't know this, but anyway. So he was introduced to amateur radio as a 6-year-old by his late uncle Callum, a ZS1 Fox X-ray, and that was circa 1962. And then in 2010, ZS1S introduced Alistair to amateur radio, and a sailing friend, ZS1TA, Tom, as we all know, to work on HF APRS. And then in October 2010, Alistair passed his RAE exams and entered the magic world of amateur radio. And he owns a lot of equipment, so I'm not going to go through that at the moment. But Alistair is also an expert. I hope, Alistair, I'm getting that right. Maybe it's professional. It depends on the wording that you want to use, on VarAC, and which is a new digital mode that is very, very popular. At this point, I'd like to hand over to Alistair. And Alistair, thank you very much for your time this evening and for doing the preparations that we can all learn about VarAC. Over to you.
Good evening, everyone, and thank you very much for this opportunity to share the background and how to use VarAC. And I will also give a bit of a spiel on what we think is the correct terminology or pronunciation of it in a moment. But thank you very much for this opportunity, and it's great being able to promote VarAC because it has a unique place in the digital modes arena. And as we go through the various slides and videos and stuff, you will see that it has a very special place at the moment. VarAC has been developed by 4 Zulu 1 Alpha Charlie, IRAD, and like several other digital software and amateur radio software, there's a play on the call sign as well. So you can see he's AC, and likewise, I think there are probably various ways of pronouncing it, but locally we've been using the VarAC pronunciation. Some people use VarAC, although I think if you want to use the play on the call sign, then the VarAC would possibly be more appropriate. VarAC is actually a suite of software. It uses the VARA modem, which is a software modulator, and that can be used either as a HF or as a FM or as a satellite modulator. And that is developed by Jose Echo Alpha 5 Hotel Victor Kilo in Spain. And we will go into detail of each of these two aspects of the software as we use the VarAC in order to move ahead. It's interesting that APRS was developed by Bob Whiskey Bravo 4 APR, and the very well-known JT8 was developed by Joe Whiskey Sierra Juliet Tango. And it's interesting that digital modes have been developed for various reasons. The very well-known FLDG was developed by David Whiskey 1 Kilo Hotel Juliet, and he was a top CW operator with a Navy background, but he started losing his hearing, and so he had to find an alternative. And he was the sort of the initial developer of the FLDG suite of software. So software has different ways of developing and has different applications. But starting with a cheeky statement now of the VarAC environment, and in a way it conveys the real purpose of VarAC being there for real conversation or real communication, rather than just exchanging signal reports. And let's now move into why digital comms. I think firstly, there's been a huge evolution in terms of the different digital or modulation techniques. Originally, it started with, with the spark systems, even before AM. Then AM came into being. And as SSB started developing, there was a bit of a polarization within the amateur community. I suppose not many were active in the 60s, but there were some that said, we're staying with AM, that's what amateur radio is all about. And some even left the amateur radio environment and didn't want to move into SSB. And now with digital modes, there's probably a similar dichotomy to some extent, but hopefully not as much as in those days. I think the real change came in the different ways that modulation was being done. To think that digital modes started with the mechanical RTTY machines, and then developed into the more electronic way of doing RTTY, and then you had MTOR, and we all know AFSK as it's used for packet radio. AX25 developed, PSK31 is still in use today, and then the all-encompassing JT8, which is very, very popular these days. And there's been a whole suite of software, and you can find most of those in various software packages. I think the major other aspect that influenced the development of digital modes is the fact that audio was being able to be digitized, and you have the USB type audio interfaces, you had SDR and DSP coming into place, and then the power of the microcomputer being able to compute all those different aspects, turning audio into ones and zeros, which could be processed numerically. Ultimately, digital modes is all about the speed and accuracy of the data that has to be transferred, and it has to deal with fading and double signals and stuff in different ways, and that is generally being done in the better digital modes these days. They should ultimately be easy to use and be able to adapt to the different situations. Which something that we don't keep in mind often is that now with digital modes, we are moving into an even more broader environment where we're looking at digital systems. So the whole radio environment has become a modem in some sense, and then you have different systems behind it being able to utilize that information, and you'll see some of it we'll demonstrate tonight, but there are other ways where you could share information now in ways that wasn't possible with audio environments. Okay, I think the other important aspect is all the information is now available digitally, and so it's data that can be stored in databases and can be analyzed later on.
I hope everyone.
Okay. This is a very simplistic table, just looking at the most basic aspects of digital modes being, is it capable of doing free text? Can it do error correction? Is it possible to use it for keyboard-to-keyboard communications? And can it be used for file transfer or for sending images? And I don't really want to go into detail with this one because we have a more detailed one coming up. And but ultimately, we can see the very popular FT8 is in a class of its own, and you'll see in a moment why. But then VarAC can actually provide all of these functions. I've got a document that I will make available the link to, in which I share a lot of detail where I've compared VarAC and JS8 Call and WinLink, comparing how the bandwidth is being used, how is it possible to share the same audio spectrum by multiple users, how do users actually interact, and can they receive notifications within the application, or what is happening while they may be busy with other aspects. an interesting aspect as well is that certain applications can't use the full ASCII character set. So, for instance, JS8 call can only do uppercase, whereas the full character set, uppercase and lowercase, and most of the other special characters can be dealt with by VarAC and WinLink, for instance, because they use the same modulator. Ultimately, who can receive the messages that we send and receive? What's the minimum radio interface? And this is probably an area of contention to some extent, in that I think with something like JS8, it's possible to use a very basic environment, similar to what you have with FT8, that you only need an audio interface and a PTT connection. You don't necessarily have to have CAT. However, you need to have computer-assisted tuning with VarAC and something like WinLink to automate tuning your systems. We compare the aspects of data transfer speeds, and obviously WinLink and VarAC use the same modulator, being VARA. But if you look at something like JS8 call, you have to manually change between modes, or change the mode in order to get better or slower throughput, whereas with VARA, all of that is done automatically within that application. Weak signal capability, and I think this is probably one of the important aspects of digital comms, that digital comms will get through where typical SSB voice communication would fail outright. And we regularly work down to minus 23 dB with VarAC and VARA, whereas an application, for instance, like JS8 call, can work down to worse levels of signal to noise ratio, but because it doesn't have error correction, most of the characters by that time would probably be in error, and you've got no idea of what the person or what the correct message actually is. They all have different levels of logging capability, but ultimately one will have to ensure that it provides what is important to you. Moving to the next slide, I think this is probably a crucial one. It's I took this from PSK Reporter on Monday morning, and you could see that on FT8 there were nearly 1,200 users, or monitors rather, whereas with JS8 call and with VarAC there were substantially fewer, or even though very similar numbers. And I think it's different horses for different courses. FT8 was fantastic for introducing digital modes to users. However, if you really want to communicate with free text and various other aspects of digital comms, you can't use FT8 for that. And we'll see later on how we can do it. The VarAC community in South Africa is relatively busy at the moment. We often have more than 20 to 30 users active, and this is some of the activity in the past week that is on the screen at the moment. Ultimately, it is about what do you want to use your applications for? What do you want to use your amateur radio equipment for, and what do you enjoy doing? Let's look at VarAC and the VarAC environment. And I think this is important that we delve into a little bit of detail of all these aspects. Beacons is the capability of a packet being sent out and announcing your system's presence on a specific frequency. And the other VarAC systems will decode it, and they will publish the beacon list on the main screen, and you can deduce different information from it. You get the call sign, you get the signal to noise ratio, so you can see where the signal, or how good the signal is, and you can also see when the last time is you received that call. Broadcast is a more encompassing communication, it's a one-to-many type of communication. However, because it's not a point-to-point connection where it can do handshaking in order to facilitate error correction, a broadcast will be sent out and you won't know which recipients have received it, and you never know what the propagation conditions are at that instant that you send it out. So at times a broadcast will get through, and 5 minutes later, if it's the conditions aren't optimal for it, then a broadcast will not get through. V-mails is the main aspect and the main communication facility of VarAC, and the V-mails are one-to-one or point-to-point connections. And for that matter, these are radio-only communication, and V-mails can be handled in different ways. V-mails can be left on your own system so that somebody will then be informed that there's a V-mail waiting for them to be picked up. You can relay it to another station, and once the recipient or the V-mail it is being sent to is that person comes online, he will beacon his, and then the relay station will announce that there is a V-mail waiting for him, and he can go and collect it. And lastly, you can also send that V-mail directly to your destination if that station is available at the time. I think something that new users often have an issue with is that they first connect and then want to create the message. However, it's better to first create your email and then connect to the station. So prepare your message beforehand and then connect to the station. And this is where VARA and VarAC has a different philosophy of use, that with each connection, you establish a connection on the calling frequency, and then the moment you've established that connection, you move off onto one of 10 working slots, and we'll look at that in more detail later on. Then there's also the basic keyboard to keyboard mode, and this is a good tactical tool where you can immediately see when somebody hits the enter or hits the send button, that text is immediately sent through, and this is typically what is used in several of the other keyboard or digital mode applications at the moment. The ability to relay messages requires a bit of a mind shift for most people. I regard it as being a bit lazy if you create a message and leave it for somebody to collect on your station, and you turn your station off immediately afterwards, because that person may get an announcement there is a message and will not be able to collect it. Your station is down. In order to, the whole philosophy behind relay messages is that it's very similar to WhatsApp, in that the recipient can respond and go and collect the message or read the message whenever they are able to. So in a way, it's a bit like a store and forward environment, and you can then go and retrieve and read the message whenever you want to. And the ability to relay a message implies then that you would go and park, the VarAC terminologies, you go and park a relay message at a station, and you go and park it at the station that is on 24 hours a day, and then you know that your recipient will be informed that there's a message as soon as they come on air. VarAC also has the capability of doing pings, and a ping is slightly different to doing a SNR request, which you can do via a broadcast, in that it is a full connection, and both stations then exchange their SNR values with each other, and the connection is then terminated. So the ping is the better way of checking whether comms is possible between your station and another station. There's a full history of all database activity, and the video actually covers, that we'll be watching in a moment, covers some of the aspects of the video or of the history, and we'll get back to that. VarAC also has according CQ capability. However, in South Africa, it seems as though it's not that popular because guys don't necessarily sit behind the keyboard ready to respond when a CQ call is being made. So it depends. Overseas, it's more popular, I think, because the user community there is much bigger, and you'll be able to get people to respond straight away. However, in South Africa, with about 25 people leaving the systems on active at the moment, but probably 1 or 2 of them would be active at the keyboard at the moment. Let's look at a video that gives you an introduction to the screen layout and what the general environment looks like. Oh, where is that gone to? Sorry, I'm gonna, oh, there it is.
In a specific band, and this is configured within one of the config files. So the system is retuned to the frequency. In terms of the different areas on the screen, you've got the beacon area, you've got the CQ calls area, where you've got all the broadcast areas, and this is the area where all the communication between your system and other systems are displayed. Right at the bottom, we have the area where you would type in messages that are sent keyboard to keyboard to another system once you are connected to that system. Looking at the beacons and the beacon facilities, this is the area where all beacons received from other stations are displayed, so you always know who is active on the system if they have their beacon capability enabled. So you would see the band in which it was received, how long ago it was received, or the actual time at what it was received, the call time of the station, the location information if it is made available. If that station has any emails waiting for you to be collected, it will be highlighted in this column. This column shows all the email gateways that are available, and for each broadcast there is an associated received signal to noise ratio value. So I could, for instance, look at all the stations that have email capabilities, and I could then right click on a particular station that has a suitable signal to noise ratio. For instance, I could select that one, right click on it, then I can connect to that station. I can ping that station. A ping is a two-way connection with SNR values being exchanged by both systems. I send an email to that station, or I can just send a broadcast to that station. I could look up the station's information on prz.com. I could also look up the PSK reported information by the internet on or for that station, or I can block that station that I don't want to interact with them anymore. Lastly, I can also bring up the call sign history, which is a built-in database of all activity. So this is all the broadcasts that I've received from that station, all the beacons that I've received with associated detail, all the broadcast information, all the previous QSOs that I've had with that station. And if I maximize this, for instance, I can go back to a specific QSO and I can see exactly what transpired during that QSO. And this is one of the very, very powerful aspects of digital comms, is having this database of information of all activity. Moving back to the main screen, if there were any CQ calls received during the time, it will be displayed here, including the slot on which you would have to interact with that station after it finished its calls. This is the area where all broadcasts are received as opposed to beacons. A broadcast is a one-to-many broadcast, and for instance here is an example of where I sent a broadcast to ZS3 Tango Golf requesting a signal to noise ratio report, and the next line that station replies back giving me a -4 dB received signal, even though I received that station at +6 dB. So you can get a lot of information via broadcast, and it is a very capable and powerful one-to-many broadcast facility. The important thing is that the broadcast is received by everybody, but there are no guarantees that somebody will receive it, because there's no handshaking to prove it as it is done within the email environment. This bottom area shows all the communications that took place between your station and other stations. So if I scroll back up, there is the activity that I just showed you up in the broadcast area of me doing the thing to ZS2 Tango Golf, and other communication would also be here. This is where I interrogated ZS1 DCC to determine which stations it had heard in the past time, and I can then, it also reports to exactly what signal strength those stations were received by ZS1 DCC, a very powerful capability. If I want to send an email to somebody, I would click on the send email button here in the middle right, and I would fill in the call sign. I could also send it as an email by clicking on that, and I would fill in the email address there. I'll put in a subject, which is limited to 50 characters. The message is limited to 500 characters. In the MCOM mode, I think it's limited to 10,000 characters, and you can also paste in CAN messages into your message, or send specific alert tags within the message that your system will respond to. You could then, if the message is incomplete, you can save it as a draft message. Alternatively, if you click on the send button, it would then post the message into the outbox folder. If you want to see all your messages, you click here in the bottom right status bar, double click on that, it opens up your VarAC mailbox, and there you have, like a typical email system, you have your inbox, you've got your sent items, you've got your outbox. The parking area is where the emails are stored that are being relayed by your station, and your incomplete draft messages would be in the draft folder. If I want to send a broadcast, I click on the broadcast button here. I can select once again whether I want to send it to all. I can, for instance, also send a, let's see if I can get one response from ZS1 DCC. I would click on send me a signal to noise report, and because that's all I want to do with this, I would then not put in a message text, and I would then click on broadcast and close, and my system will go off and transmit that broadcast. There you can see the broadcast going out at the moment, and it will then wait for a reply from the station. Here we see the reply coming back from the station, and if it is successfully decoded, it will also be displayed in the message area. Looking at the broadcast area, there you can see is the broadcast that was sent by myself, and the response from ZS1 DCC that it received me at -7 dB, and I heard ZS1 DCC at -16 dB. Any interaction with another station where SNR values are exchanged will be displayed here in the top right, and you would then have the signal of what that station is receiving your station at, and the SNR values that you are receiving from interacting with that station. This screen layout is the simple screen layout here in the top right hand corner. You could then go and select an advanced layout that gives you some additional options. Here there are options added to this area. You have the detail of the interaction between your VarAC application and VARA being displayed here. There's some additional options here. For instance, there's a ping option which wasn't available from this area. You have to right click on a beacon or station name somewhere to get the ping option available. And so lastly, there's also a MCOM mode, but we request guys not to misuse this, because your station will be announced as an MCOM station via RF, and it will be displayed in red here in the beacon area, and generally it should only be used for real MCOM environments.
Okay, that was a very fast introduction just to the interface. And then moving on to the next slide, if I can get back to it. Okay, so I don't think I'm going to be looking at more detail with the general VarAC philosophy. Let's look at the screens you've just seen. This is the simple layout screen. It's got fewer options here on the right-hand side. It has fewer options here at the connect button. And then the next option, I've highlighted the differences between the two screens. This is the advanced layout screen. So you can see it has the area there where you have the comms detail between VarAC and VARA, and you can select either the standard 500 hertz bandwidth for VARA or the 2300 hertz, and you've got extra options here. We'll look into the inquire option later on. You can put out a request to find the path to a station that you wasn't being displayed in the beacon area, and so it carries on. And when you create text here in the bottom, when you enter text here at the bottom and hit enter, it then goes into queue area here and in the middle, and then once it's ready to be transmitted, it'll go out into the currently sending area. So this is the two primary screen layouts that VarAC users use. Looking at the VARA modulator. So we've looked at the VarAC environment. We'll now focus a little on the VARA modulator environment. And I think the most important aspect about the VARA modulator is the fact that it uses error correction. So whatever information is received on the other side will be error-free at all times, or it will not be able to communicate. If we look at the VARA screen itself, let's look at the layout here. This graph shows you the throughput at the time. And in a case where you have a blank line like that, the packet wouldn't have gotten through, and it would have to restart again and then build up speed as it continues. Here on the right-hand side is the constellation diagrams of the particular modulation being used, and that layout changes dramatically as the modulation is adapted in terms of the different conditions. On the right-hand side meter here, the signal to noise meter, the green area is down to minus 15 dB, yellow goes down to minus 20, and then anything in red is minus 20 and worse. So we've often worked down to minus 23 dB, and it will eventually get through and without any errors. The AFC meter refers to the frequency error between your system and the system you have connected to. And ideally, you shouldn't have an error of more than about 15 hertz, which is still here within the green area, because that will, if your error is more than 15 hertz, then it starts affecting how long it takes to establish a connection. And in a way, it also has a negative influence in terms of the throughput capabilities. This is the CPU utilization, and ideally, you shouldn't go beyond about 80% CPU utilization, otherwise it starts losing packets or creating error conditions. And but if you have a fast PC,
Alistair, we've lost audio. Alistair, we've lost your screen.
Issue, and I think anything survive, but ideally, and we look at. Can you not hear me at all now?
Sorry.
1, 2, 3. Double check that I'm getting out again. Let's move back. Yes. Okay.
Yeah, you're coming out again, but it stopped the screen, so you just need to share again.
Okay, I'm resharing. Is it visible now?
It's visible, but you're on the notes screen.
Okay, wrong screen. Apologies. So stop sharing and okay, let's go on to that one. Yes, correct one. Is that fine? You should
No,
see the map. No, okay. Let's stop
no,
again.
wrong screen.
Apologies. No, that's my notes. Sorry, I'm taking time to get the right screen. There's so many screens here.
No issues.
No, not the right one. Yes, there we go. Allow. Can you see it now?
100%, you're back.
Okay, thank you very much. Let me just get back to my notes. There we are. So, yes, we've spoken about the CPU meter. Then the VU meter is the volume level of your signal going out of your transceiver to your PC. And for HF, ideally, there should be in the 50% area. If it goes beyond about 80%, then you start getting distortion and so on, and your throughput will no longer be optimal. However, with VarAC FM, I've found with some of the tests I've done, it seems as though it prefers having high volume levels. But there are ways that can be tested. These buttons here in the center are actually the protocol buttons, and they flash depending on what is happening with the communication at that instant. So whether it's doing handshaking or sending data. Here at the bottom, you can see this is the arrow indicates that you are downloading to this VarAC at the moment, and that it is dealing with a packet of 420 bytes, and it's on a level 2 modulation, which is running at 41 bits per second. And with a 500 hertz signal, you'll have a narrow waterfall like this, between which the signal is sent. If running at 2300 hertz, it opens up much wider, most of the screen, and then it has different ways of dealing with it. VarAC has multiple modulation levels, and it deals with it in interesting ways. This is the table that is available from Jose, the author of the software, and we mostly use the 500 hertz narrow bandwidth for HF. You can also use the 2300 hertz bandwidth, and as I've said, please don't use that on the standard working slots, because 2300 hertz bandwidth will knock out four normal working slots, and will blot out the usable frequency totally. So if you're using 2300 hertz, move off the standard calling frequencies to something that you've determined yourself. This horizontal line shows the break point between using the unlicensed versus the licensed version of VarAC. So with the unlicensed environment, it is very usable, and you will often find, particularly on HF, that you need pretty good conditions, and unless you're communicating with somebody close by or that has a very good signal, then you don't necessarily go beyond this area. Using VarAC as an unlicensed product gives you enough time to decide whether you want to spend any money on it. You'll also notice that the throughput difference between the narrow and the 2300 hertz isn't substantial at this level 4 modulation, but as you start moving down the modulation levels, let's look at level 10. For instance, here you're working at 200 or 2000 bits per second versus 884, so it's more than double the speed. assuming there's no interference. And it seems as though, okay, we'll move on to the next slide first. Now, where did I put the other? Okay. Or was it? Looking at the other aspects of VarAC, these are two different screens that come up depending on how you use the menus. On the left-hand side, is the one where you would select your USB audio interface card for VarAC at the time, and you would at the later stage set your drive levels accordingly, and there's a methodology that you would use. If you're using a single instance of VarAC, then you wouldn't need to fidget with the TCP port IP addresses, or port addresses, not IP addresses. However, if you're running multiple instances of it, for instance, if you're running HF as well as VHF simultaneously, then you would use different port addresses here. Normally, one would fill in your call sign here, because when VarAC connects to another instance, it needs to know who it is connecting to, and it gets the information from here. So your call sign is filled in here, and your license, if you get one, will go in there. Otherwise, that remains blank. Looking at the other detail in here, if you want VarAC to be checked for updates, you would enable that. For VarAC, you would always enable the 500 Hertz because that's the default mode with VarAC. You would enable the KISS interface because it uses that for broadcasts. And depending on your operational environment, you may or may not want to disable its response to data carrier detect signals from the VarAC environment. The number of retries, if you're using something like WinLink, for instance, using 15 retries is fine, because you sometimes have to do 2 or 3 cycles to before you connect. However, with VarAC, I've never had a station connect after the 8th attempt. So I typically set this at 10 for VarAC. Okay. If you move on to the VarAC interface, again, here's a lot of reference material for those technical guys that want to go and check on how it's done and how to optimize the environment. But also, if you want to buy the license, the option is here, and ultimately it'll open up a web page. And whoops, what happened there? Okay, let's go back to that again. Okay, and you will get to the please pay. At the moment, the cost of a VarAC license is 64 euros. If it's a single license, if you can club together with a group of people, 10 or more, the price drops down to 50 euro. That's worth being patient and maybe clubbing together and getting 10 or more licenses at the same time. The important thing.
Here we have an example of VarAC.
Whoops. Okay, let's quickly do this. Oops, sorry. If we look at this, then one has to ultimately decide whether you want to get the license or not. And I think for most people, while you're getting to know the product and want to make a decision whether it's worth spending the money, don't get the license. But ultimately, if you want to use it seriously, then it's worth buying the license, and particularly if you can club together and get it at 50 euros. The next slide is a demo on VarAC FM, and that is slightly different. This is you'll also see the color interface of the VarAC screen is different, and we are showing you how a connection is made on VarAC FM.
Here we have an example of VarAC using FM with a VarAC FM modulator. I've turned off reduces the CPU usage to some extent. We have a email in the outbox. If I click on the outbox there, you can see it's ready to be sent. So if I now connect to the other station, my one station is a portable station, the other one is a base station. So if I connect to it, that will immediately connect, and you will now see the interaction here taking place. There it's already connected, and it is now exchanging signal to noise values initially, and because we're not on a normal calling frequency, we'll immediately continue with a standard exchange of information. So here we have the connection taking place, and we seem to have an issue with the email. Let's go and check it. So I will open the outbox again. I will double click on that. I will edit it, and it seems to be okay. So that's not happy with the reply to address, so I will pull that in again. I will update, and it is now. And immediately you will see, let's close this window, there the message is lying ready to be sent. It's already been sent. The delivery has been successful, and now it will also tell me that the email was sent via the internet successfully, so they're successfully connected to the system. So VarAC FM is much quicker than VarAC. Typically, I've seen throughput values in excess of 7,500 bits per second, and depending on the quality of your signal, other folks have seen up to 25 kilobits per second throughput. So if you're in a suitable environment when this can be used, it's an amazing tool to use.
Okay, then the next video is a comparison or looking at both instances of VarAC on two different PCs while it's exchanging data. It's actually doing a WinLink connection, but it would be identical in the VarAC environment.
On this screen, we currently have two instances of VarAC FM, each running on a different PC, each connected to a different VHF radio, and we will soon be engaging in a file transfer between the two systems. If you watch the status bar, you will see the direction, an arrow with a direction indicating whether data is being received or transmitted. And likewise, on this area here, you will see the modulation level and the throughput, the bits per second being throughput at the time. And this will be adapting depending on whether the system is handshaking or whether it is actually busy with a larger file transfer. It seems as though the initial handshaking takes place at about 586 bits per second, but then as the file starts being transferred, the throughput will be negotiated depending on the conditions at the time. Here we've initiated the connection, so it will now be exchanging handshaking information, and you can see the throughput initially on level 1 at 566 bits per second, but then as it continues with the process, it will then ramp up the speed to be able to transfer the file. So let us wait and see how it continues. The graph here at the top shows the throughput for each packet going through. So it started with an initial packet at 500 bits per second, then it ramps up here to the order of 2,390 bits per second, and it will adapt the speed as conditions change and so on. So in this case, we have a file that's being transferred, and the two systems will keep on exchanging signal to noise with level ratios with each other while it's actually increasing and adapting the speed. Now the speed has increased to 4,000 bits per second, and it's close close on 6,000 bits per second there, ramping up as the file is being transferred. And this is with the licensed version of VarAC. They had lost the packet, and now it's lowering the throughput to adapt to the conditions. So it's interesting to see how VarAC actually does its negotiations. It's lost the packet again, but it's continuing. And whatever gets through will be error-free, and that's the beauty of the VarAC environment. Well, the file transfer is completed, and you can see both systems are disconnected, and it is now awaiting further instructions from the application that manages it.
So this was to give you an idea of the modulator aspect of the VarAC environment, and that modulation being done by the VarAC application. Now let's move on to look at how do we start using VarAC. Some tips and tricks initially. Most people want to start by calling CQ, and I would recommend, particularly in the South African environment, you're probably going to be lucky if somebody responds, but you're welcome to try. There's some other stuff you can do in the meantime, and that's what I would like to show you and discuss here. Firstly, go and check out what is happening in your broadcast environment. There's no point in calling CQ if you haven't got any entries in the broadcast or the beacon area. So at the moment, ZS6 Whiskey Hotel Lima, if I'm correct, is doing AI research, and he's posting information via broadcasts, and that takes up some space in the broadcast area, but you will also find other people using broadcasts from time to time. So initiate broadcasts or beacons and see what happens to it. And ultimately, it's best to go and respond to it. Right click on it and connect to it, because then if you see there's activity, there's somebody you can talk to. And that's one of the reasons why it's being listed on the screens. And then send VMails to stations who have beacon. So you know it's somebody that's active. You can see how long ago they've made a call and connect to them directly. First, compile a VMail, or if you want to, you can go keyboard to keyboard and chat with the guy, assuming that he is at his PC at the moment. A very easy way of getting to know the VarAC and VarAC environment is to use the inquiries facility. And you would first connect to a workstation, or sorry, to a station, and then you would click on the inquire button on the right hand side, and you can then send queries to the remote station, and it will report back in terms of the query that you've sent. So you can request it to send you an SNR report. You can send an info request, and it will reply back with the information that the owner of that station has put in his information area in his application. So that tells you who he is, where his QTH is, what transceiver is using, what antennas is using, and what his hobbies are. Those are the main features of the info area. If you click on location or locator, it'll reply back the location of the user, and the more recent versions of VarAC now also has built-in GPS capabilities, so it could report back live GPS information if it's available. A feature I often use is to inquire who a station has heard. So there's normally a button before this one is displayed. So you do a click on that one, and then you can select report all stations that you have heard, and it'll reply back to when it heard it and what the signal to noise ratio was. You can also make queries about a specific station if you wish. Also, VarAC has the ability to automatically run a frequency scheduler, and it will then change frequencies at the scheduled times. And by sending that query, the system will report back what the frequency schedule is, and whether it's active at the moment or not. So one thing to watch out for is, for instance, be aware that if you're communicating with a station at the time that the scheduler needs to kick in, I know the previous versions of VarAC would change frequency irrespective. I'm not sure whether that has been changed in the latest versions yet, but you could lose a connection if you happen to be connected to a station at the time it's scheduled to change frequency. You can also go and determine all the VMAILs that you've parked at a station. In other words, if you wanted to use that station as a relay station, it will report back all the messages that you've parked there, and whether those have been collected in the meantime. So you would know then whether the person you've designated to send a VMAIL to, whether they've received your VMail or not. Or you could, for instance, if there hasn't been a response via this station, you could go use a different relay station and go and park the same message or similar message at more than one relay station. And then if you're in the MCOM mode, then this provides feedback on the last 5 connections. So this, using the Inquire facility, is a nice way of playing around without interfering too much with the many options that are available within VarAC, and you can independently get to know the environment. Within VarAC, the logs of all QSOs are generated automatically, and it's saved in an ADIF file. If you have a certain set of logging systems that you use, VarAC, I think there is a list of about 5 of them that it will interface with directly, and it can then also report directly to that system. I think an important aspect of VarAC is that it is a rather all-encompassing system, and it has many features, and I would highly recommend that you watch additional videos to get a more comprehensive understanding of how it's used. And often it's something, a small mistake that you may make, and it wouldn't respond the way that you would expect it to do. Something that I wouldn't say addicted to, but close to that. Whenever I make or try and make a connection, I always watch what happens on the VarAC screen. In my case, I normally work remotely. I'm not in my radio room. I'm elsewhere in the house, and I connect to that PC via remote desktop, and hence I can't hear any activity on the receiver itself. And that's why I always watch VarAC to see what's happening, and I get a very good idea of the activity at the time. How does one get started? Digital modes are difficult for many people because you're using multiple environments and you need to be aware of them, and we'll discuss some of them later. Most important, that's why I've put all these toroids on here, is the impact of RFI. Especially with something like WinLink and VarAC, the overs can be very long, half an hour sometimes if you have a large file that you want to transfer. And if you have any RFI sensitivity, particularly in the USB cables, it may bomb out. So if your system is unstable in any way, it's most likely that it is RFI in the cables. One of the ways to deal with that is lower your power, because with digital mode, you seldom have to go above 30 watts. And dropping down to something like 30 watts is a good start. Alternatively, go down to 10 watts and see whether you still have the problem with RFI. And then you use as many as necessary toroids on your USB cables, and ideally you should use a screened USB cable because they are more resistant to RFI. Your radio interface is a wide subject, and this is probably where most of the guys get unstuck moving into digital modes, because depending on your systems and your radio in particular will determine how complex it is. Looking at the volume levels, this is the Windows Sound Manager screen. You would have to set your output from your PC to your radio, which effectively goes to the microphone or to the modulator. And then in the same way, you would also have to set the recording volume levels of your Windows environment to have a suitable signal. But this is not all. You also have to set, if you're using something like Signal Link as your digital interface between your PC and your radio, that volume has to be set, as well as the volume levels or sensitivity on your transceiver. And once again, it depends on what type of transceiver you have. So in essence, you have to typically watch for 2 or 3 levels, volume levels, when setting your audio interface. And it can be quite overbearing initially. So one would typically start with installing VarAC and VarA, and you can then decide at the time whether you want to install VarA HF only or VarA HF as well as VarA FM. And then the whole issue around the requirement of needing a CAT control. Just to be difficult, I started trying to use that as well, but you have to change frequency so often that trying to use a manual in an environment where you have to change your frequency or change to a different memory channel is just a major slip. So it's highly advised to always use an auto QSY environment. The reason being is this is the frequency selection screen when you want to QSY from the working channel to the working slot. So there would be 5 working slots at lower than the calling frequency and 5 slots above it. And you would then have to select one of those and then first sniff that frequency to see whether there is activity on it. And then once you know it is not in use, you would click the and activate the QSY invitation. It's just good operating behavior to always check that you're not clobbering somebody else who's already active on a working channel. At this stage, South Africa isn't that busy, particularly on 40 meters, but in some of the past exercises we've noticed that the moment you get more users that's active on it at the same time, having good operating discipline is vital. So it's absolutely necessary to ensure good operating discipline. So once again, you initiate your connect or your call on a calling frequency, and the moment you are connected, and the status screen will show you that you have successfully connected, you select an alternate working frequency or working slot. The proper terminology for IC is it's a working slot, and then ultimately initiate the QSY. This is the frequency selection drop-down menu in VarAC, and these are all the standard calling frequencies. However, you can go and edit this and add as many as you wish. And remember, with each calling frequencies, there should be sufficient space associated for the 10 working channels. So if you want to use 2300 baud, 2300 hertz bandwidth connections, then you have to plan your calling frequency accordingly, that you don't clobber other working environments with your working channels. So, for instance, in an MCOM environment, you would predefine those frequencies with a suitable title lower down in the list, and retain your standard frequencies here. Moving back to that, we've looked at the auto QSY facility, and then looking at the audio interface. When setting up your PC for digital modes, you will always have to be aware of 2 serial ports if you're using a separate PTT port for or a separate PTT control, and then the second port would be used for CAT control, and your audio interface would have to be displayed here. Whether you have a audio interface built into your radio, whether you're using an external USB audio interface, it has to be displayed here. Likewise, the only time you won't have a second serial port here is if your PTT is managed or handled via CAT commands, and that is more common with the more advanced modern radios. Okay, moving on from this one, we've spoken about the CAT controls. I think an important misconcept with digital modes is that it's all about the signal strength. It's actually more important having a signal with 0 distortion than having a strong signal. So spend time to ensure that you don't overmodulate your signals, that you have disabled all digital filters and DSP and compression. All of that should be turned off with digital modes. As you develop your practical experience with it, you can eventually start using filtering, but it has to be used in a specific way, because often VARA and VarAC would manage interference better than DSP environments or filters would be able to do. I think guys shouldn't be scared of QSYing once you connect, because that's one of the most basic aspects of using VarAC, is getting off the calling frequency as quickly as possible onto a working slot, and then you can spend as much time there as you wish. Using beacons is the way that you would get to know who else is active on the on a specific band at the time, and then going back to your VarAC screen, using the columns and sorting the data there is how you would actually utilize your beacon environment appropriately. As I've said, I would highly recommend that you watch videos, and ultimately it's about also reading your manual. Looking at your hardware requirements, some guys are having success at the moment still with Windows 7, but it's essential that you are able to upgrade your libraries, your .NET libraries, to versions 4.6. But you need to have the latest library, and it's not necessarily the version number that's important, it's how recent that specific version is. VarAC currently still works on Windows 7. Some of the WinLink applications have stopped working with Windows 7 because it's using libraries that are no longer available in Windows 7. Windows 11 comes with an idiosyncrasy in that for whatever reason, you are unable to define a default audio output device. And that means that one of the capabilities of VarAC is that it makes voice announcements of different things happening. For instance, you're connecting or you're receiving a beacon from a certain station, that there can be voice announcements about that. And if you have voice announcements turned on Windows 7, it then actually sends those announcements over the RF output channel, and you shouldn't be doing that. So unfortunately, at the moment, you can't use voice announcements with Windows 11. Whether that's been rectified, I can't say at the moment. Another cause of great instability is Windows updates. And Windows often messes with the USB serial port drivers and installs the latest one, which is often not compatible, and then you will have to revert to the one that works for you, and your system will be down until you've done that. It also changes with some other drivers, and I've often heard people struggling with VarAC or digital modes subsequent to a Windows update. And this brings us to an interesting concept of whether you should use a dedicated PC for your radio. And it's something that I've started doing more recently, in that I have made my PC accessible via my local area network, so I can access it via Wi-Fi, but that PC cannot talk to the internet. I've specifically set up an incorrect default gateway address on it, so it can't go out via the internet. And I no longer have problems with Windows updates, and I have, because I'm accessing that PC from a laptop or from a tablet or a cell phone, that device then has full access to the internet, but the radio PC is then isolated from the internet and gives you extra stability. As I've mentioned, I specifically use remote access to my PC, excuse me, and with Windows 10, that had a remote desktop bug at the time. I'm not sure whether that's been resolved, but I've standardized on using VNC. Excuse me. I've installed a tight VNC server on the PC, and then I can access it remotely, and it's all shareware. I don't have issues with accessing it. So I can access my VarAC environment from my phone, from a tablet, or any remote PC. And the remote PC is then dependent on whether that PC is on my local LAN, and if you can also set it up in a way, excuse me, that your system is accessible from the internet, but via VPN. There are ways of doing that as well. Moving on, these are the default frequencies, and those are the frequencies that have been defined in the default frequency list that we showed you moments ago, and that is where you would connect, whether you're on HF or VHF. This is the minimum requirements, the official minimum requirements for VarAC and VarA. They actually state Windows 8.1, but as they've said here, there are some people that get Windows 7 working. I had a system that worked like that for some time, and but you never know when either of the two packages that you use will eventually require features or libraries that are no longer available in Windows 7. The minimum screen resolution required to be able to view the VarAC screen, and the application itself is relatively tiny, but then as you use it, it builds the database, and that grows, and all the logging and stuff. So eventually you will need more than 10 megs of space for the additional information. What is happening in terms of VarAC environment at the moment? We've got a local VarAC South Africa WhatsApp group at the moment. We've had several exercises, some happening at Thursdays on 19:30. The most recent ones were at 8 o'clock because of propagation conditions, 40-meter band closing at the time that we want to exercise. So we have had exercises, and we've also tried to use digital modes for a call-in net, and we've experimented with it, and in a way we've developed a procedure that sort of emulates the typical Sunday morning call-in bulletin call-in environment for SARL, and it works effectively, but we could probably still streamline it a little further. In a similar way to the VarAC Wednesday, the WinLink Wednesday, there's now a VarAC Wednesday where you have to send an email via VarAC gateways with certain content, and then they log you, and it reports back. And it's only been running for a couple of weeks, and the past last Thursday they've grown to beyond the 128 users participating. It's interesting that the WinLink system, the WinLink Wednesday system test has been run for about 4 years. They have about 3,300 users that participate in that. So VarAC is now also doing something similar. We've had some exercises in the past where we've had the exercise coordinator parks a relay message at a relay station, being relay 1, and then it's addressed to participant 1, who will then receive a notification from relay 1 that there is a V-mail for him. He would then download the V-mail, find instructions in the V-mail of whom to pass on the message. So he's got to park it at another designated relay station, and that content is then addressed to somebody else, the participant 2, who is notified the moment that relay message is sent there, and he would then collect his message and then send it on via an email gateway back to the exercise coordinator. So that's one of the we've had 2 or 3 of these exercises in the near past. And this is one of the more humorous slides we've had to advertise the slide. So, yeah, you've got to be ready for action. VarAC is a new environment, and this humorous slide actually gives an idea of what the implications could be if you don't read the manual. So we highly recommend that you read the manual and also watch some videos, which may be the quicker way of getting behind what is involved with this whole environment. We've got some related reference material, and these are the two VarAC and the VARA URLs where you can get their software and all their reference material and stuff. These are the 2 recommended videos. The first one is a 3-minute overview of the features, and it just runs through on the screen. And what's nice about it, you can go back and check exactly where the guys clicked and see how it's used the specific feature. The next one is a long video. I think it's a 40-minute video, which looks at how to configure your VarAC, and it goes into a lot of detail, but it's worth watching it once you get into it. Donnie's, there is one, Oscar Sierra. Sierra has got a very good background page and detail on VarAC, and we've now also sort of put together some videos and information at this URL, how to use relay messages, how to use the I'm away option if I don't have CAT capabilities, and what the implications are, etc., etc. So we've tried to put some additional useful information there for new guys starting up with VarAC. So this is my last slide, and I think ultimately VarAC is about providing effective communications for RAG queuing, for general comms, for transferring information, emailing, files, photos. For MCOM, it's ideal for, it's got an MCOM mode, and ultimately for having fun. Thank you very much. Back to you, Keith.